derivatives and rates of change. 2.7 if we're still hanging out in this Stewart text. We're going to move into it, kind of the point of Calc 1, derivatives. And it kind of says rates of change. Here it is, a derivative. It's the instantaneous rate of change. And maybe at a point. That shouldn't mean all that much. Maybe unless you have a little prior knowledge. So derivatives, we think of like slope. Slope is our way of finding the average rate of change. And when we were in algebra, that was about the best we could do. Now we're going to move in and essentially, like I'm going to misspeak. We're going to find the slope of curves. We're not really. There's no slope of a curve, but we're going to figure out what that instantaneous rate of change is at any point. Here we go. It's calculus. So before we do that, we got to be speaking the same language. So we need to know what a secant line is and a tangent line. A secant line and a tangent line. So first let's describe a secant line. And I figured, you know what's best? We just draw you a picture of what a secant line is. Maybe we're going to take a point right here. I'm going to call this one A. And we're going to take some point over here. And we're going to call this one B. All right. Neato. Neato. The line that's secant between A and B. Oh, watch this. I mean, I imagine you're gonna be shocked by this. You're gonna be like, oh, no way. Could it be the line that connects the two things? Yep. There's the secant line between point A and B of our function. And let's call it something. I'm being a little sloppy. Let's say y is equal to f of x. That we're just calling this curvy thing. I don't know, just something f of x. I don't know. It looks like a cubic almost, huh? Almost like a cubic third degree polynomial. Whatever. Okay. So if this point is A and this is our function, I think over here this is f of A. Which means you're going to take this number A and you plug it into that function, and it's going to give out the height. That's just going to get you that height, huh? So actually, I don't like it sitting like this. Look at that A underneath there. It's just bothering me. A. All right. And then for B up here, right over here, this height, you know, something like that. My drawing sucks. Bear with me. I do my best. So that's some f of b. So our points are right down here. You have a, comma, f of a. Whatever the hell those numbers are. Those are both numbers. We just don't know what they are, and we have to use this shitty notation. But as we get better with it, we start to learn to read it. And that's really what you need to be able to do to get into like Calc 2, Calc 3, stuff like that. You got to be able to read the math. And right at first, it's rough. So, all right, bro. Let's go find the equation of a secant line. You already know this. It's just this line. It's this line. You already know this formula. Let me just write it a little bit differently for you. Remember this from algebra? Remember that shit from algebra? Yeah, you remember that from algebra. At least, if you don't, whoa. Whoa. All right. So let's just call it something. Like, let's call this one x1, because it's just a number. And we'll call the other one, oh, we're not going to call it x2. We're going to call this one y1. It's the first point. And over here we got x2 comma y2. It's another point. It's just a different way of talking about it. So what ends up happening is we plug it in and we're like, okay, so our formula is our y2. y2 is just f of b. All right, f of b. Minus, what's it say? And then we go minus y1. Where's y1? y1's right here, so they're not going to write in y1, we're going to write in f of a. And then down below, we're going to write in, okay, our x2, where's our x2 at? Where's our x2? X2's up here, and that's just b, okay, so we'll plug in b minus, and then we got to go find again, we got to go find, where's that x1, and that x1's right there, that's a. All right, cool. So that's the slope of the secant line. It just connects 2 points together, right? There's a curve. Right? We're actually looking at a curve here. But to connect it, it's called the secant line. So let's write this in. Our secant line has a slope. It's equal to f of b. Oops, I need to move. I'm in the wrong spot here. Sorry to waste your time. Move to the right. So our secant line has a slope of f of b minus f of a all over b minus a. It's your slope formula, dude. It's just that, and it's also known, the secant line, it's also known as the average value. If you took college algebra, you should have had to do this a few times. It's like at the beginning of the course, but may not even remember doing it. But we call it the average value, or the secant line. All right, cool. This is algebra. This doesn't have anything to do with calculus yet. Cool. It's the slope formula. All right, so that's the secant. We got to be able to speak the same language. Well, here's my other shitty drawing. I mean, just look at this in here. What the heck happened? And that's not even the surface. That's just me sucking. All right. Now we're going to talk about something called the tangent line. Now, the tangent line is something we mess with all the time in calculus. The slope of the tangent line is actually something we're always looking for this thing. We're always searching in Calc 1. It's kind of the game. But even when we don't say it, we're looking for it. Now, here's a tangent line. Now, there's not an A and a B. It just wants to know what kisses right off of it. So let's say we have some point A right here. I don't know, some point A. Actually, you know what? I don't want to use A. I don't want to use A. I want to use C. I want to use C. I want to use a different letter. And maybe we put it right, so we're like, where is it? It goes up to here. Now, what does the slope look like right there if we were just to kiss it right off? So we could just, what, like that? Is that going to be perfect? Like right how it's, could that represent? And we just kind of do something like this and kind of make a line right through and go, that's the tangent line to the curve. Y equals f of x at x equals c. That's a mouthful, but you're going to see it in your other stuff. So, but we're just saying that's a tangent line at a value of x equaling c down here. I don't know. So maybe for example, you're like 7. So we're going to talk about the slope of a tangent line because it tells us how this is actually growing right here, like right here. It's telling us instantaneously how quick is that function growing. Remember slope? We just did it. That shows you how quickly a function is increasing or decreasing by a slope. It's a rate of change. Take your foot off the accelerator while you're driving. I shouldn't say accelerator, and you will slow down. So your function velocity is decreasing. So maybe we go along. Here it is. We're going and you're hitting the gas. So the y-axis is speed. Go to here and all of a sudden you take your foot off the gas, start to slow down. And then you're like, screw that, I'm going to hit the gas again and take off. So what we're finding is our change in our velocity would be any one of those little slopes there. I know it's a tough one, but I'm just trying to get the terminology. If you catch nothing else, then the tangent line is the thing that just kisses off the function, and that the secant line is actually like the two dots being connected. Cool, you did a great job. Terrific. We're almost done. I'm gonna draw another tangent line. Let's put it over here. I'm gonna call this D. And get out now. It's like, well, what's looks pretty negative, right? Remember that negative slope stuff we had from like drawing lines? We can be like, oh, there we go. There's a tangent line to that point right there. It just kisses right off and tries to mimic what the, let's put air quotes up, the slope might be, because the slope of the tangent line is going to represent the instantaneous rate of change of that curve, otherwise known as dun dun dun, the derivative. So we're going to move into this. This was just a lead-in to talk about what a tangent line is, what a secant line is. Next comes calculus. So I will see you in the next.